starting stream. All right, go for it.
Okay, let me share my doc here. Okay, so what I want to talk about is the async compilation stuff. There's basically two purposes here. One is I'm trying to make a document so that we can explain to managers like what this is and what we're doing. And also I want to kind of gather thoughts about it to see if people know of any kind of dark alleys that we're about to wander down that we should, at least ask some questions about. Okay, so the basic goal of this thing is to allow PyTorch programs to start actually running stuff immediately while the slow compilation happens in the background. That's kind of one of the goals. Another goal is that way, if you have 20 or 200 or 2,000 machines all compiling the same thing, we actually only do the compilation once, and then we share that compilation across all those machines to save some cycles. Okay, so that's sort of the why are we doing this? Maybe there's more.
Actually,
Anyone think?
I have some commentary about the why, which is
Yeah.
so one other thing that I would add is you want the compile products that every node is running to be the same, because if the nodes make different decisions about things, like because there's some non-determinism, that can result in divergence in performance and potentially lead to nickel timeouts. So the other comment I make is like I'm not sure which of these goals I'd actually put as primary, right? So like one of the discussions we had that led into this was essentially, like how do I make sure all my inductor code gets auto-tuned the same way when it's compiled on all the ranks, right? And that's like
Mhm.
just that's like self-motivating because we were looking for reasons why PyTorch 2 could cause nickel timeouts. Now, we can solve this other ways. It doesn't have to be solved this way, but that was like one of the original things. And then the other thing was like, why do we want PyTorch to start executing immediately with eager while compilation in the background? Was actually not because we want to improve utilization, although that is nice and we can put that as a goal. But it was actually because we wanted to have the ability to compare how much faster the compiled code was to the eager code, which requires us to run some run iterations of eager at the beginning. And that actually I think is very very important, because if we have that number, then we can have an ongoing how much is PyTorch 2 helping you on a fleet wide basis all the time. So also getting to not waste GPU cycles at the beginning, that's also nice too. That can be as a self justification, but it's actually kind of hard for me to put which one is first. Maybe we do if we run into hard design problems, but the nice thing about remote execution compilation is it kind of solves all of these simultaneously. So that I find very satisfying about it.
Yeah, totally reasonable. Uh, okay. Anybody else?
As I
Oh,
mentioned, there's one additional benefit here where like yesterday we were talking about how like we have these local caches, we have these remote caches, and if we all unite under array, then we can just have local caches that will get shared across array instances, and we won't have to roll out our custom architect, custom like caching, what's it called, like remote services. I
okay.
would again consider this to be a minor benefit because we would still have to build everything we're building right now, except instead of using custom storage, we would be able to use RE storage. So it's not like a significant improvement. It's just like a cherry on top.
Sure. That makes sense. Uh, didn't see anything else. Okay. Continuing on. Okay, so overall, there's some questions, right? Which is like, what's going to be covered under this RE cache, at least initially. And uh, so starting with the FX graph cache, that's probably a good place to start. We know it's cached. Because it's cached, we know we can rely on the stuff underneath that not caring about actually running, you know. And so that's probably not a bad place to start. know if there's opinions on that. Then there's this other overall question, which is, do we need to care about, RE reliability? There's been issues in the past with some of the teams using RE have had, some problems with the reliability, but it does have a whole team supporting it. So one could argue that, rather than our own team supporting things with reliability, maybe some other team supporting the reliability and them actually caring about high reliability is a good thing. Also, right now, we don't have our own RE tenant, so the P90 latency is high, which means we might want to either provide a PyTorch tenant or require big clients to have their own tenant if they care about latency. So these are just, some questions. Elias.
If we fall back to local compilation, we'll have to be careful about any compilation that uses memory.
Just because of worrying about running out of it.
Yeah, just because of concurrent use with the eager, which might lead to them.
Right. Okay. Yeah, that makes sense. I think Colin was next.
The RE tenant side of things. This is all going to go into a doc, and there'll be more conversations here. But I spent a little bit of time this week talking to RE, and the rough TLDR is they don't really have a lot of multi-tenancy features right now, but they're planning to add them over this half. And I expect that, essentially PyTorch will end up using those features and talking to them. But also, the current agreement with Triton, which, Ogas is correctly pointed out, doesn't appear to always be working, but is essentially like, hey, if RE is down, Triton just falls back to eager mode. And so it's worth thinking about the failure mode here. And, I don't have a good answer here. Like, I think if RE is down and we go into eager mode, right, like some models straight up won't work is my understanding. So like, we'd have to do the side compilation, but if we're doing that, like it may not work because of memory issues or other things. So like we should figure out what we want to do here, but like this is sort of the current state. Hopefully that was useful.
Yeah.
NYC.
I vaguely heard that a lot of the performance regression we had also lead to SEVs. And I'm curious about the RE reliability question, if fallback is actually a valid option for us.
Actually, I rose my hand to talk about this. So actually, in some cases, we can't fall back. This is peculiar to the Facebook deployment situation. But if you need to compile C++ code with the GCC LLVM toolchain, we actually do not have this toolchain available on the workers running mass jobs. So like if you have compilation that requires that, and in particular, this is the Triton remote execution is using this, you're out of luck. You have to use RE. We don't have another choice unless anyone in this room has like updated information.
When I was talking to Bert about it, he said that this is something actually we can fix, but the RE was at the time, I think he said something like the RE was the easiest way to go about it. So I think we should actually figure out how to fix this instead of relying on something else to deal with like compilation toolchain.
Okay, but like it was not easy because like the compile toolchain is big and you have to deploy it across all machines. And do you really want to be compiling C++ code on your expensive H100 nodes?
Yeah. New question here, but can we not fall back to eager mode here? Like we literally do not have an eager mode backup for these compilations.
So for the Triton cache specifically, if you have a Triton kernel, you can't run that, and you have to actually compile it. I don't know. Okay. I don't know if the Triton thing has like a Python wrapper that you can use instead to avoid doing the C++ wrapper, because they certainly could have done that to avoid it. I think there definitely exists like a configuration of our system where local fallback is possible, but I just am pointing out that sometimes it's not so easy to do local fallback.
So I think something to consider here is like this is no worse than where we are right now, right? Because our current situation would be we would be compiling ignoring Triton right now. Right now we would be compiling on this machine. So instead of compiling on this machine, we would shell out the remote execution machine. So if we fall back, we would fall back to the machine we would be originally doing the compilation anyway. This is not the case. This is not the same for Triton because Triton literally cannot compile on this machine. Triton has to use remote execution. But for the case of FX, I guess for a case of like anything PT2 related, that's not a concern for us, right?
So there's one more thing, which is that if you want to run compilation in parallel with eager, because you're doing the warm up while you're compiling, you basically let me think. You must do the GPU auto tuning off host because that GPU auto tuning will use up CUDA memory, and you'll easily use up too much memory if you're also trying to do that concurrently with eager mode. I think everything else is like okay. I mean, you'll also get some CPU contention if you try to run the. You basically shouldn't. You shouldn't actually try to run eager ahead if you have to do local fallback. NYC.
Oh, on the note of the we need to do the GPU auto tuning off host. Does RE give an easy way to given whatever GPU we're actually running for the model, get the same GPU in RE to do the auto tuning on?
That is a good question. That is actually one of the unknowns.
So what I've been told is that yes, you can get specific GPUs in RE. The backup plan, by the way, for GPU auto tuning is we just run our own auto tuning service without using RE. So that's like another thing you can do if you are in this situation.
Yeah, most of the things in this doc, like they're not really specific to RE. This could totally apply to our own service, just doing the work ourselves. And there are hybrids, right? Like we could write our own execution service, but use CAS, which is the actual caching that RE uses. So there is some middle ground as well.
Also, a note for our open source listeners in on this. So RE is a remote execution service that Facebook runs internally. It actually is a well-defined API that has a number of open source offerings that do it. So yes, in principle, the open source story would be you would run one of those services and then plug PyTorch 2 into it. Colin?
Oh, I was just gonna chat about how there's probably a couple more design points here areas we could think about here. One thing is, we're going to be talking to RE either way, but it might be possible to get them to essentially provide like a stricter SLA where we go like, hey, no, we're not going to build the fallback, and we want you guys to be available 5 nines or whatever. And if that isn't there, bad things are going to happen. Like that might be something that we can chat with them about. Like this is a significant amount of usage and a significant, priority for the company. So there might be some wiggle room there. Like we shouldn't completely throw it out now before we talk to them. And also just chatting about GPU availability. I know they have A100s. I think they have H100s, but some of the older models, I think they're getting rid of. I don't think they have P100s anymore, and they might not have V100s. And I don't think that really matters to us because I don't think this stuff even works on P100s, but we should double check the GPU requirements here. And the other thing that we should flag is if we do need GPU on RE, we're going to have a pretty crisp capacity story here where we go hey, this saves the company 20 or 30%. Thus, we think it's okay to levy a 0.05% tax across the entire GPU fleet so we can pay RE because we're going to want some amount of dedicated GPUs. And I think that's the most straightforward way to get it.
Elias?
We can move on from memory stuff soon, but just also throwing in a couple ideas. I mean, could we just wait to do the memory requiring things in Inductor at the end of the optimizer step when memory's at a low, or that I don't know if that would result in echo timeouts for eager, but potentially, yeah, just an idea. And another thing is I think we could reduce the amount of memory that we need in compilation. I had a PR for this that I didn't end up landing just because it was a little bit risky maybe and not needed at the time, but you know, when we benchmark, we have we have read inputs and then we have written outputs, and like we can just reuse the memory for like the inputs we read from the system without like doing new allocations, and that would reduce memory like a good amount. And I had a PR that just like basically took a view on parameters from the modules for the like non-written to benchmark values, and like it did reduce memory. I just didn't land it because it wasn't needed at the time. But like I don't know, just a couple ideas.
I think New York was next.
Yeah, I just wanted to quickly jump back add to your comment about we cannot fall back if we don't have a compilation tool chain. How does that link with the original goal of, we run eager or something else, while we compile?
Well, I
So
mean,
that
eager,
is-
you don't have to compile anything, so you're good.
Okay. So
No,
the
you
assumption
still
is
do.
every compiled artifact has an equivalent eager code that requires 0 compilation.
This is not true for like Triton custom kernels. Well, I guess it kind of is true if you treat Triton as its own thing. But yeah, a lot of models that we run have fully working eager versions that can be done all the way through.
So I think
Okay.
there's like so just one second. The right now Triton cannot compile in eager mode either, which means that if right now I don't think Triton will be able to execute on production hosts unless it uses remote execution. So this is like I guess I kind of want to divorce this like there are two different stories here. One about like PT2, one about Inductor, one about Triton, and Triton is somewhat like reliant on remote execution because it actually cannot compile on production host. So even like doesn't matter if it's like torch compile or eager mode.
And this is why the Triton code has its own currently RE backend.
Yeah, so you hit that RE backend even if you're not using PyTorch 2 at all.
Right.
Yeah.
So presumably if we're having a reliability issue with RE, Triton will also be having a reliability issue with RE, and so we're gonna have problems either way.
Yeah. I do want to clear up that like this compilation toolchain is not a problem for like the I guess PyTorch compilation proper. It is a problem for like Triton compilation, which is something we should fix. But I do think that like this discussion we should mostly focus on the PyTorch sides, not the Triton side.
I mean, it is potentially a problem if you're using CPU wrapper. Elias, do you still have a hand? Ooze, I guess you don't have a hand either.
I do.
Okay, go.
I did want to talk a bit about the GPU usage. So something that's like interesting about PT2 compilation is right now, like in order to compile something with Torch compile, we have a machine with GPUs and CPUs, and we use the entire time we're compiling, we're using this machine that has like GPU resources. However, like 95% of the compilation doesn't actually use a GPU. So if we were to use remote execution, we could do some sort of like hybrid approach where we compile on a CPU machine and we do some sort of like shelling out to a GPU machine so that we do the auto tuning or like anything else that uses a GPU, like the pad MM optimization and stuff like that. This means that we would be able to reduce our GPU usage by, I guess, technically 95%. So there's like, even though we will have to get more GPUs on RE to satisfy our needs, when we look at the overall fleet, the 95% of the compile time for GPU usage would actually be reduced. If that makes sense.
And one consequence of this is that Inductor needs to be able to cross-compile to CUDA without actually having a version of PyTorch that has CUDA available. It can be compiled with CUDA support, but it can't require CUDA to actually be available. Colin?
Sorry for going back to this earlier discussion, but I just wanted to sort of circle back to the fallback here. Like my sort of assumption is, look, if we built this RE system and RE is down, it seems a lot safer to just stop execution while we compile rather than trying to like optimize memory and, do all this other stuff. Like we're already in a bad situation. We don't want to have like a low rate of failures. So I just wanted to make sure that people were thinking about that, because I think that's just the safest approach. And like we're not running on RE, we built this system, and it's broken, we're already in a degraded state, and it's probably better to be safe and degraded than, make a trade-off of a little bit more risk for a little bit more, capacity.
And I guess you'd be okay if there was a flag that you could manually use to
Yeah,
intervene.
I have no objection to having flags during a SEV for people to do stuff. Sounds good to me. I just want the default to not have crashes, or else we'll have 2 SEVs at once, and it's going to be confusing.
Right. I mean, there's still some question about the nickel timeouts in that situation, but yeah.
Yeah, no, I agree with you there.
Okay. Okay, so I guess moving on, the next question is like, what's the actual milestones that we want to look for? There's basically 4 as I see it. So I'm just gonna run through the what they are just as a preview, and then we'll come back and see if people have comments or questions. But it's basically moving the compilation of the FX graph stuff to a sub-process, then taking that and getting that sub-process to actually run on RE, but with a machine that's actually got a GPU. Then removing the GPU requirement, and finally overlapping these things, running eager and async at the same time. That's kind of the 4 steps that I see for having it. So, returning back to that first one. So moving the compilation of FX graph to a sub-process, this lets us actually see that we're pushing the right data down there. The things I could think of that were unknown is like, other than the graph itself and the target information, what parts of compilation that depend on like the current program being compiled also need to be transferred over. How many of the guards or anything like that. And we already do some of this with the inductor workers, and so there may be some overlap there that we can kind of take some work and reuse some of that. Colin, did you have your hand up still?
Sorry, no, leftover.
Okay.
I have
Edward.
a quick comment, which is we don't have to do these in order. Like the de-GPUification of inductor can happen in parallel to isolation to a sub-process. That's all.
The de-GPUification.
Yeah, remove the GPU requirement.
Yes, that's true. And furthermore, the running eager while waiting for compilation doesn't have to wait for RE. Like once we've moved stuff to a sub-process, we can do that as well.
You can also just not do that step at all, and
we can also just not do that step at all. That's right. Like there is some independent. This is a graph. It's not necessarily a list. Okay. So the second step, moving the compilation of FX graph to RE with a GPU, I think it's pretty straightforward. Basically once you have stuff in a separate sub-process, just getting RE to do that is going to be pretty straightforward. Again, as we said before, like making sure that the RE workers have the right exact GPU for what we want to build is sort of a question. And there's also this other issue, which is that RE is very hermetic. And we've talked about this before with other things where, like is the hermetic input of that cache too strict? Like, do we want to actually loosen that? There are ways we can do this. I think that will work. But I think like step 1, just getting it to work, we want to be, as hermetic as possible, and then we can kind of loosen things as necessary. Oz, I think, was first.
So something I'm kind of curious here is, like, for example, for ads training, for most of the CMF models, they are using this thing called like the shampoo optimizer. And shampoo optimizer doesn't change at all. Like the entire time they have the same training platform, the shampoo optimizer doesn't change at all because it's like the same optimizer. But different ads models use this optimizer. It all creates different graphs. With the current, I guess, remote cache implementation, we are able to just compile this shampoo optimizer once, and we're able to reuse it in every time CMF is compiled. I guess like something that I think would be an important requirement here is making sure we can still maintain this type of behavior, and like RE's strict input strictness doesn't prevent us from actually sharing this type of I guess graph caching.
Right. Right. Okay. Colin?
I had somewhat similar questions here, which was like my memory of RE is that like your stuff should be usable if it's deterministic. Like you give it a command to run, it will run it, it will cache the output, and then you need to be able to get the cached output back. And my question here was, given that we already are running a cache, like what's the difference that we're expecting that will break here? Like I was a little confused by that. Like essentially, shouldn't our RE inputs line up with the cache keys we're using today for the FX graph cache?
Yeah, the issue isn't that it won't work. The issue is it'll be too tight and we won't actually get enough sharing out of it. Like, basically every version of FB code would cause a different cache hit. And so therefore, two people that are one rev different, like if you're hashing on the FB code rev, if that doesn't,
Mhm.
if your hermetic input is the FB code rev, if that doesn't change PyTorch at all, like then why are we including that in the key? So it's just a matter of being too tight on the key.
Got it. Okay, so we're worried about not getting enough caching.
Yeah.
I actually have an even more basic thing I want to point out, which is that for most trainers that I am looking at, we actually, ideally, I would like to compile the same graph on every rank, and this does not happen for dumb reasons. Usually it's because they have device 0, device 1, device 2, device 3, and so forth. So they're all different. So like I fail to do any sharing across processes on a trainer.
Isn't this also because like they just embed the rank number into the graph, which is I guess that's how the device numberings end up there. Can we
Well,
make devices
also
be
because
dynamically based?
what we should do is the trainers should use CUDA visible devices to hide the other devices for each process, so that you only ever see device index 0. That also helps with avoiding accidentally reinitializing CUDA context on 0, which has caused ooms in a lot of situations. I mean, we could also think about like adding support for symbolic device index. I think that's actually surprisingly feasible. We would just like civinify the device index inside device. I just haven't really looked into like how easy or hard that would be. Colin?
Oh, sorry. Just leftover hand.
Okay. The next milestone's removing the GPU requirement. Oh,
Sorry,
Yeah.
do we have anyone from distributed here actually? If we could get some ideas on the visible devices change visibility. Okay, I guess not. We can take that offline then.
One thing I'll point out is that like we can fix torch run fairly easily in open source, but we have like n trainers internally, and each one of them needs to get fixed one by one. And Chirag is a good person to ask about this, actually.
okay. Okay, so the next milestone will be removing the GPU requirement. So like this is taking the stuff from the last step and making it so we can cross compile on a machine that doesn't actually have a GPU. In the theory, we can install the tool chain and just run it. I mean, that's the hope. The reality, I mean, I guess we'll find out when we get there, right? But current unknowns, like, if we have, there was some question of whether we need the NVCC compiler or, like how deep we have to go on the stack. Um, and then getting that, shoehorning that into the, FB code, third-party repo. And then do we actually, it's possible we actually need a GPU to do things like auto tuning and things like that. So can we, uh, can we split the jobs up into multiple parts that then the parts that actually do require a GPU, we only do the smallest piece of that on the GPU. Colin?
I wanted to echo Ogus's point earlier. MVCC, we don't need that for PT2 compile, right? That's just a Triton dependency, right?
Yeah, I wasn't sure about that, so I listed it.
Okay.
I'm not sure.
Yeah, I mean, I'm not sure either. I was just going off the previous.
I know that when the VCC compiler cannot be found on my path, it's not able to like compile correctly.
Got it.
Right. I mean, it's just Triton, but also Triton is a dependency of building some of this stuff. So
Yeah, and I guess that's the question, right? Like, do you run Triton afterwards and call back into RE, or do you do it all at one step on RE?
right.
So I will
Right.
say NVCC is super capable of cross-compiling because actually in our CI we build our CUDA stuff on CPU machines and then we schlep them over to GPU machines to run the tests. Triton though is a little more murky because there's like some integrated auto tuning, so you'd have to extract these. I don't even know how the Triton RE stuff works. So that's certainly a question.
Yeah, I mean, Bert pointed me at their code just as an example of them using RE. So I do know where the code lives, but yeah. But yeah, I mean, it's the question isn't I guess the question isn't really can NVCC run when there's no GPU. It's more of like getting it into our infrastructure and the details there. So all that. Colin, did you have another question or just a stale hand?
Sorry, I'm really bad at this. No other question. Thank you.
That's fine. Okay, and then the fourth milestone is actually going in async and running ahead with eager while we're doing compilation. The hopeful thing here is that this way, instead of somebody having to wait for a compilation to go, they can actually get some stuff happening in the foreground, and then when the compilation's done, maybe we either slide it in for the next run or slide it in during the middle of the current run. That'd be really kind of cool. Again, questions about if we've got different accuracies going on, is that going to affect things poorly? Is it a legit thing to change the compilation mode in the middle? So there are some questions here. As pointed out earlier, these steps don't necessarily have to run in order. We can do, step 4 can be investigated while we're doing steps 2 and 3, and or we could just choose not to do it. But I figure I wanted to list these things out. Comments or questions on that one? No? Okay. Colin.
I just wanted to flag here, and maybe we don't want to talk about this here, but like getting data on how well Eager performs while we're doing compilation is going to be really, really useful for a whole bunch of stuff. Like this is sort of what a lot of people outside of PyTorch want to see, and we don't really have this data today. So I just wanted to flag that if at all possible, I would really like to have this data. And I think there's some ways to do it without sort of blocking on migrating to RE that I'm probably going to chat with Ed and a bunch of other people about. But I just wanted to flag that this data is really useful. So if we can get it, that would be nice.
So I'm a little curious about I guess the accuracy problem. Like, how big of a problem is the accuracy difference right now? I know that yesterday there was a task that Richard and Elias were discussing about how Inductor the compiled version is more accurate than the eager version due to the downcasting and stuff like that. Is this actually going to be a problem if we execute it with compile and eager and end up with different results?
Yeah, I think we need somebody who's more familiar with the actual models to answer that. So open question, I guess.
Okay, I have a more meta question, and we can wrap this up, which is that one of the biggest requests from open source is just, hey, can I compile my thing and then reload the compiled products so I don't have to wait for compiling over and over again? They didn't ask for remote execution, like system, like that's not what they want. They just want like, some stuff that they can dump on like a file system and then use it consistently when they want to like keep rerunning a training job.
Isn't this AOTI?
No, not AOTI, because it's still like their Python training script. Okay, so I just want to like check that. Is there like a intermediate step we can slot in somewhere here which like directly solves the open source need?
So I guess the file system caches that we have built should more or less deal with this. There will still like it's not a guaranteed hit because they have to actually be running the same model.
Yeah, but that it's pretty common for that's just what I'm planning to do. So
I mean-
do we have the APIs to like conveniently do this?
Ed, didn't you, Horace, and I have like a 2 hour long
Yes,
conversation?
we did, and we
Yeah.
like came up with this sticky cache idea, and then I think we were like, well, we're going to wait for AOT autograd caching to exist before pushing on this more. But I don't know. I mean, maybe we should like just do it, like, because if Inductor cache is enough to start talking about remote execution, then like Inductor cache is probably enough to start talking about sticky cache as well. Honestly.
Sorry,
But
why do we need sticky cache? Like, why can't we just like if right now, like I think in OSS Sam turned it on by default to have like FX graph cache in disk. Why is that not enough? At least for Inductor side. And then once we have the autograd, that will be, I guess, quote unquote enough for autograd.
yeah, I
So,
thought
like,
the
Dynamo-
whole point behind the sticky cache, at least my recollection from Horace's talk about it, was that it was like weakening the keys so that it applied to more things, not so much that it's just having a cache or no cache. So I thought that was the thought behind sticky cache.
Yeah, that proposal was about not like being sound, having a non-sound option, so which I think we should exclude from this like discussion.
Right. If they're just running the same thing over and over again, then sticky cache wasn't needed, just warm cache is needed.
You know what? Actually, I remember why we're blocked on AOT autograd. So, right, exactly. The point of sticky cache was we were going to reduce the dynamo safety stuff that needed to be done so that we would just not bother doing guards and go straight to the compiled product. But there's no compiled product to go to because we can't serialize the AOT autograd function. So, like, you still have to run Dynamo to run AOT autograd, and then you finally have the thing which, you now can pull up the Inductor compile results. So, okay, fine. James, you're our only hope.
I don't think he's here.
Okay.
I guess before we move on, I'm kind of curious to hear like what's the temperature of the room in terms of this like proposal for at least like I guess starting with internal. Is there anything like people are like super like worried about? Anything that people are excited about? Yeah, I guess how does the room feel about this?
One thing I'm worried about is like just buffing up the like instrumentation. I mean, I know folks have been working on that anyway, but like for instance, we had like a big compilation latency increase recently, and like we still want to catch those even if we are async compiling. Yeah, it's just like instrumentation difficulty of like not catching things we would have otherwise.
This might actually help with this because when you do stuff in array, it increases the reproducibility. You'll be able to run the exact same like array command and hopefully run the exact same code again. So we will be able to test things, I hope.
Anyone else? Okay. So that's it for me.
All right. I don't know if it's Jeffrey or Joel, but take it away, NJT.
Okay, I'll start out and then I'll pass it off to Jeffrey. Can you see my screen?
Yes.
Okay, great. Okay, so background here, trying to avoid graph breaks and hard errors when doing NJT construction in graph. Some background here. So nested ints are the way we model ragged structure. We maintain a mapping between the metadata tensors, offsets, or lengths, and the nested int within a nested int registry today. And we increment those as we see new offsets come through. What we want to get here, and this isn't the case today, is we want to be able to full graph compile these sort of NJT construction in graph. And the reason why this doesn't work today, very briefly, is because of the various fake and functional tensors that are created during tracing that conceptually refer to the same object as the real source, but they end up getting associated with a different ragged structure naively. So yeah, this sort of maintaining this relationship between the real and the fake nested in, symbolic nested in is not done consistently today. So we end up with all sorts of problems. Questions on that? Okay. So I think the longer term solution that's been discussed before is use a union find to maintain these equivalence relationships. This is something Jeffrey's been working on for a while. It's a big overhaul. It's kind of risky to implement. It changes like the nature of equality for nested tensors, for example. So we need something like short term to unblock some use cases, specifically adds inference on AOTI, depends on this full graph. So we need this to work kind of today. The approach I'm taking here is to kind of expand the usage of the nested in registry to comprehensively include the proper like fake tensor to symbolic nested in entries also within the registry. So what this entails is during fakeification of these metadata tensors, also symbolicize any associated nested ints, store those entries within the registry. Further, for fake tensors that have never previously been associated with the nested int, but then take part in NJT construction and graph, on the fly, create a new unbacked symbolic nested int and add that entry to the registry alongside the fake tensor. And then there's a few conceptual equivalences that AOT Autograd creates for various reasons, and we need to also maintain those in the registry. Finally, functional tensors always contain fake tensors during tracing, so you can unwrap those and pull out the fake tensor and store that in the registry as well. So doing this sort of comprehensive overhaul to make sure that all fake tensor to symbolic nested in entries are within the registry seems to fixes a lot of these issues that come from like doing this inconsistently. Now that said, this is just one way to approach it, and a way that leans more towards the longer term solution is moving away from the nested int registry towards Jeffrey's design to have nested ints maintain like store offsets like on them. So his approach here within this other PR moves away from that registry usage and prefers to store the symbolic nested ints directly onto fake tensors. And I'll let Jeffrey talk about the details of that. But I think conceptually, the maintenance of these equivalences between real and fake tensors is still the issue to solve here. So Jeffrey, do you want to talk about the details of your PR here?
Sure. Or I guess, do people have any questions on sort of the high level things that Joel, I guess, talked about?
So is this basically like, let's not change any semantics of nested tensor right now?
Yes.
And then what we're going to do is I guess if it was just like nested tensor contains more tensors, then you fakeify the nested tensors and the outer tensor, and that would be fine. But I guess the sticking point is the nested int registry. And so you're just going to put a bunch of fake tensor entries in that registry as well?
Yeah, that's the goal of my PR, to like keep the usage of the registry pretty much the same, but then make sure that those entries with fake tensors are comprehensively there. And that conceptual relationships between things that AOT autograd creates that are intended to be equivalent have the same ragged structure and also are maintained within the registry. Or in the case of Jeffrey's PR, store those symbolic necedents directly onto the fake tensor and don't use the registry for that.
And we're not going to land your PR. Jeffrey's PR assumes yours.
Sorry?
Does Jeffrey's PR subsume yours, or?
Yeah, so I think that based on previous discussion of storing the symbolic necedent onto the fake tensor directly as the way to go, I think Jeffrey's PR subsumes mine because it goes that route, moves away from the registry. So yes. Elias?
Yeah, we could not be following everything exactly, but so fake tensor already has this like concept of like non-zero memo and item memo and unique memo, which is like basically for the purpose of associating like cements that are recalled to make sure that like the equivalence is set. Maybe Ed would know better than I would,
Actually,
but
they
like
did some
yeah.
memo-y thing in their PR that I haven't quite understood. But yes, there's something
I'm,
similar.
I'm we're using the memo now, so I updated the PR.
Okay.
Yeah, I think this is along the lines of what already exists.
The main issue is the existing memo, like it specialized front and back cements. So I'm adding this flag. The issue is that we don't actually want to like invalidate the memo when the epoch is different for this case, versus front and back we do want to validate. So like that's like one difference. But adding this flag sort of allows us to reuse the memo.
Cool.
Well, Jeffrey, do you want to present?
Sure. So I guess I wanted to like talk about a couple like interesting things that as me and Joel ran into while designing this. And there's like this large comment block that you guys can like look at on the PR if you're if there's for more details. But I guess at a high level, there are a couple of different problems. One problem is that today nest tensors rely on kind of global state. So we track every time we have sort of this offsets tensor, we associate it with a sort of unique ID and incrementing ID. So like every time we create some kind of new nest tensor, we have to keep track of the current counter. So that's like one global state we keep track of. And when you have global state, you kind of want to, like there's two properties I want to satisfy when like compiling. Like we want to avoid mutating the seeker state during tracing. And we also want to like make sure that when we run the compile function, like the side effects are like replayed in sort of the same way. Like me and Brian also talked about this a little bit in the context of like later PR or this PR stack, but I think a lot of the ideas also transfer here. So like in this case, like the reason it's hard to do today is because like the side effect gets traced away during tracing. The reason that happens because like we have the torch dispatch, the constructor is a torch dispatch function, we trace through the torch dispatch, and the side effect goes away. The way around this, you could imagine like having a custom function that wraps this like side effect. It survives until inductor, and during eager, it would run the side effect properly. And we need some kind of like effect token system to make sure that this doesn't go away. So that's like one approach we plan to do in the like later stack. But for the purpose of this PR, I think the moral is that like the high levels, we want to have something kind of simpler, like something minimal just to support the case you want to support, and avoid doing more complicated things for now. Also, side effects don't, or effect tokens don't work with subclasses today. I think someone's working on it, but it's not there yet. So like there's still work to do to get it working properly. But in the meantime, I think this is not a real problem. in terms of correctness. Like the issue is that in some cases, compile might differ from eager, but it's correct. I don't know if we want to talk about this one a bit more, but there are also a couple other points or questions so far on that one.
On the correctness part, are you saying if we like just land the current PR that adds the like extra that like makes the registry correct in fake tensor world, but then we don't do the extra runtime side effect stuff, that there like aren't correctness problems that we'll run into?
Right. Like I think the trick here is that what happens is you create new offsets in the dense graph. And what happens is that ALT autograd ends up like seeing that these offsets or this NJT is part of the outputs, and then once it tries to rewrap those offsets into the NJTs, it triggers the eager logic, and that would like increment the ID or put it in the registry or whatever you want. So like in practice, like due to that sort of trick, it mostly works. There are two cases where it doesn't work. Case one is you return two nested tensors. The order in which you rewrap the outputs is based on the order you return the tensors, but that might be different from the order in which you constructed the NJTs. So like eager would differ from compile in this case. The second case is where you return a nested int, but you don't return the corresponding NJT. In this case, like it's wrong because we didn't actually increment the counter, but we returned to the ID. That's kind of like wrong. The reason the second case doesn't matter is because we don't even support it. It like errors out for other reasons. So like in practice, like even though this is kind of like weird, it does seem to do the trick. Is like it's high level.
Okay, thanks.
I have, I guess, the opposite question, which is, are there side effects? It doesn't feel like side effects to me.
I guess like one side effect you might want to do, like let's say you increment, you create an NJT in the graph, and you return it. That NJT has some accident. Like let's say it's the first NJT created ever, so its accident would be 0. You want side effect to be I increment the global counter, so that next time I create a new accident outside or new NJT outside the graph, like my accident would be 1, not 0. Otherwise, it'd be like the two bragginess would be like incorrectly assigned to the same incident.
But I guess you're just totally failing. Oh, is this the 2 NJT case? So if I return 2 NJTs where they are based off of the same index tensor, you're going to give them distinct nested-ins, aren't you?
I think we should give them the same one. So what happened is like during runtime, LTI get runtime wrapper, when it's constructing the first one, it caches it. So the second time sees that it's already cached, and it would be the same, I think.
Yeah, so it's back to my. Is there a side like you mentioned some sort of long-term plan to like explicitly model the side effect, but I'm just kind of like, is there a side effect? Doesn't seem like there's a side effect.
Or let me do an example. I guess one example is let's say you have a function that offsets return an NJT from that. So you compile this function and you run it with VO, and then you run it again, or with, I guess, with new ones. So what, like, do you imagine NT0 and NT1 to have the same, like we want the side effect of this to be global counter, so that when you run this, so like we want the side effect to be like that. It would actually increment the counter here.
But it
That makes
does,
sense.
right? Because when I run the compiled function and the
Yeah.
AOT autograd runtime wrapper code, it has to construct an NJT.
Yes.
And it'll increment it. And then you're like, well, what if we just don't return the NJT?
Oh, okay.
But then it doesn't
Yeah.
matter because, you know, there's no way you could have like observed the old nested in any way because it doesn't.
No, I think we agree then. So like we don't need side effect is like the moral of the story. I think we agree. Yeah. We'll eventually need side effects for the long term with unified, but not today.
Yeah, but I don't. Okay. Maybe with unified, there's like some unification effect that you need to model. Okay, sure.
Okay.
NYC.
All right, moving on.
And yeah, we gotta wrap it up soon. But go ahead.
Okay.
That's what I was gonna say. So yeah, nothing else.
All right. Thank you for presenting.
All right. See ya.
All right. See y'all.